You've probably heard someone mention IPv6 at some point. Maybe your router settings have this mysterious toggle for it, or you saw it buried in your network configuration and thought, what even is that? And honestly, you're not alone. Most people just ignore it, assume it's some tech thing that doesn't matter, and move on with their lives. But here's the thing, IPv6 isn't just some random upgrade that nerds get excited about. It's actually the only reason the internet can keep growing the way it has been. Without it, we'd have hit a wall years ago. And yet, even though it's been around since the late 90s, the world has been painfully slow to adopt it. So what's going on? Why do we need it, and why has the switch taken so long? Alright, let's back up for a second. To understand IPv6, you need to know what came before it, which is IPv4. IPv4 is the Internet Protocol version 4, and it's basically the system that's been running the internet since the early 80s. Think of it as the address system for the internet. Every device that connects to the internet needs an address so data knows where to go. It's like how every house on a street has a number, so the mail carrier doesn't just throw your package at a random door. IPv4 uses 32-bit addresses. If that sounds like gibberish, don't worry. It just means each address is made up of 32 ones and zeros, which translates to about 4.3 billion possible unique addresses. Back in the day, when the internet was just a handful of universities and research labs, that seemed like more than enough. They probably thought, 4 billion addresses? We'll never run out of those. Spoiler alert, they were wrong. Fast forward to today, and we've got smartphones, tablets, smart TVs, smart refrigerators, smart toasters, probably smart socks at this point. Every single one of those devices needs an IP address to connect to the internet. And with over 8 billion people on the planet, many of whom own multiple devices, 4 billion addresses suddenly doesn't seem like very many. So what did we do? Well, we got creative. One of the main workarounds was something called Network Address Translation, or NAT. NAT is kind of like an apartment building. You've got one street address for the whole building, but inside there are dozens of apartments with their own numbers. So two completely different apartment buildings across town can both have an apartment 5, and the mail still gets delivered correctly because the street address is different. NAT does the same thing with IP addresses. Your home router has one public IP address that the internet sees, but all your devices inside your house have private IP addresses that only your router knows about. When your phone wants to load a web page, your router translates that private address into the public one, sends the request out, and then routes the response back to your phone. Pretty clever, right? And that works. It's kept the internet running for years, but it's also kind of a patch job. It adds extra steps to everything, which slows things down a bit. It also makes peer-to-peer connections, like video calls or file sharing, way more complicated because devices can't talk directly to each other. They have to go through middlemen. Plus, NAT wasn't designed to be a permanent solution. It was more like, we'll do this for now and figure out the real fix later. Enter IPv6. IPv6 is Internet Protocol version 6, and it was designed to solve the address shortage once and for all. Instead of 32-bit addresses, IPv6 uses 128-bit addresses. And the jump from 32 to 128 bits, that's not just a little upgrade, that's an absolutely absurd increase. With IPv6, we go from 4 billion addresses to about 340 undecillion addresses. That's a 340 followed by 36 zeros. To put that in perspective, you could give every single grain of sand on Earth its own IP address and still have addresses left over. Every person alive could own billions of devices and we still wouldn't run out. It's genuinely overkill, but in the best way possible. So IPv6 solves the address problem. But that's not all it does. The people who designed it also took the opportunity to fix a bunch of other annoying things about IPv4. For one, IPv6 addresses are structured in a way that makes routing faster and more efficient. In IPv4, the header, which is basically the label on a data packet that tells routers where it's going, has a bunch of fields that aren't really necessary anymore. IPv6 simplifies that header. It's actually bigger because the addresses are longer, but it cuts out a lot of the extra junk, so routers can process packets faster. IPv6 also has built-in support for auto-configuration. In IPv4, when your device connects to a network, it usually needs something called DHCP to assign it an address. DHCP is like a receptionist handing out visitor badges. It works, but it's one more thing that can go wrong. With IPv6, devices can generate their own addresses automatically without needing a DHCP server. They just look at the network, figure out what addresses are being used, and create one for themselves that fits the pattern. It's way more seamless. Another thing IPv6 improves is security. IPv4 was built in a time when the internet was a much smaller, more trusting place. Security was kind of an afterthought. IPv6 was designed with modern security in mind. It has built-in support for IPsec, which encrypts and authenticates data, making it much harder for someone to intercept or tamper with your traffic. And because IPv6 has so many addresses, we don't need NAT anymore. Every device can have its own unique public IP address. That might sound scary at first, like, wait, doesn't that mean every device is exposed to the internet? But actually, it's fine. Firewalls still exist, and they work just as well with IPv6. The difference is that devices can connect directly to each other without all the translation nonsense, which makes things like video calls, gaming, and file sharing way smoother. So IPv6 is better in pretty much every way. More addresses, faster routing, better security, simpler configuration. It's basically everything we wanted IPv4 to be. So why isn't everyone using it already? Great question. The short answer is compatibility, or rather, the lack of it. IPv4 and IPv6 are not compatible with each other. An IPv4 only device cannot talk to an IPv6 only device without some kind of translation in between. It's like if half the world spoke English and the other half spoke Mandarin, and nobody had a translator. You'd need everyone to switch at the same time for it to work smoothly. And that's just not realistic. Most modern devices, your phone, your computer, your game console, they all support IPv6 already. Windows, Mac, Linux, iOS, Android, they've all had IPv6 support for years. So the problem isn't really on the consumer side. The problem is internet service providers. ISPs are the ones dragging their feet. And there are a few reasons for that. First, upgrading all their equipment to support IPv6 is expensive. Routers, servers, infrastructure, all of it needs to be updated or replaced. And a lot of ISPs looked at that cost and thought, well, NAT is working fine for now, so why bother? Second, there's no obvious benefit that they can market to customers. Imagine trying to sell someone on IPv6. Hey, sign up for our new plan and you'll get the same internet, but with a different address format. It's not exactly a compelling sales pitch. Most people don't know or care what IP version they're using as long as their Netflix loads. And third, and this is the sketchy part, NAT gives ISPs control. Because all your devices are hidden behind one public IP address, your ISP can see and control all the traffic going in and out of your network more easily. Switching to IPv6, where every device has its own public address, makes that harder. And some ISPs aren't exactly eager to give up that visibility and control, but despite all that, IPv6 adoption is actually happening. It's just been slow. As of 2026, around 40 to 50% of internet traffic worldwide is over IPv6, depending on the region. Some countries are way ahead. India, for example, has over 70% IPv6 adoption. The US is somewhere around 50%. Other places are lagging behind, but the trend is moving in the right direction. Part of what's helped is that most networks now run what's called dual stack. That means they support both IPv4 and IPv6 at the same time. So your device can use IPv6 when it's available and fall back to IPv4 when it's not. It's not the cleanest solution, but it's a practical way to ease the transition. Another thing that's pushing adoption is the fact that we genuinely are running out of IPv4 addresses. All 4.3 billion of them have technically been allocated. There's a secondary market where companies buy and sell unused IPv4 addresses, and the prices keep going up. At some point, it just becomes cheaper and easier to switch to IPv6 than to keep fighting over the scraps of IPv4. Mobile networks have been some of the biggest drivers of IPv6 adoption. T-Mobile in the US, for example, has been almost entirely IPv6 for years. Mobile carriers are dealing with millions of devices, and IPv6 just makes way more sense for them than trying to juggle NAT and limited address space. So, what does all this mean for you? Honestly, if you're just a regular person using the internet, you probably won't notice much of a difference. Your device will use IPv6 when it can, IPv4 when it has to, and everything will just work. You don't need to do anything special. But if you're into networking, or you run servers, or you just like tinkering with tech, it's worth understanding how IPv6 works. The addresses look different. They're longer and written in hexadecimal with colons instead of dots. An IPv4 address looks like 192.168.1.1. An IPv6 address looks like 2 001 colon 0db 8 colon 85 A3 colon 0000 colon 0000 colon 8 A2 E colon 0370 colon 7334. Yeah, it's a mouthful, but there are shorthand rules to make them easier to write, like dropping leading zeros and collapsing runs of zeros into a double colon. And if you ever want to check if a website supports IPv6, you can visit test-ipv6.com or ipv6-test.com. They'll tell you if your connection is IPv6 ready and show you what address you're using. The future of the internet is IPv6. That's not really up for debate anymore. The only question is how long it's going to take for the whole world to get there. And based on how things are going, we'll probably be running dual stack networks for a while longer. But eventually, IPv4 will fade into the background and IPv6 will just be the internet. No version number needed. So yeah, that's IPv6. It's not some distant future tech. It's here, it's working, and it's slowly but surely taking over. You might not see it, but it's happening in the background, making sure the internet can keep growing and connecting more devices, more people, more everything. And honestly, that's kind of cool. If you want to mess around with IPv6 yourself, check your router settings. Most modern routers have an IPv6 option you can enable. Turn it on, reboot, and see what happens. Your devices will probably just pick up an IPv6 address automatically, and you'll be part of the future of the internet, or at least the present that's finally catching up.